and welcome to Chapter 6, Section 2, Chemical Bonds. Chemical bonds are the glue that holds the atoms together in a compound. So when you've got a compound with two or more atoms in it, it's the how they bond that we're talking about in this section. And the bonds form using electrons. And there are two ways to do this, and this whole section is just about the two ways. So the first way is called an ionic bond. That's an I-O-N-I-C. Ionic bond. And this forms when highly reactive elements lose or gain extra electrons. When that happens, they form ions. Now, highly reactive elements are the ones that are near the edges of the periodic table. So remember, the ones on the far left are very reactive, and not the ones on the far right, because they're the noble gases and they're inert. They stay there. It's the ones next to that. So it's in the second and the third and the fourth from the end. Those columns that are highly reactive. So the ones on the left side of the periodic table have one or two extra electrons in their outer shell that they like to lose, while the ones near the right, they have one or two extra holes that they're trying to fill, and so they like sucking extra electrons in. And when they do that, when the guys on the left lose theirs or the guys on the right gain extras, then they've got this negative charge that they've either lost or they've gained, and so that gives them an electrical charge. Ions have charges. They get this electrical charge, and so if you lose an extra electron, you have a negative charge, and if you gained or a positive charge, and if you gain an extra electron, then you have a negative charge. Now, if you've got these ions that are floating around with these charges, the opposite charges attract. So you've got a positive charge floating around and you've got a negative charge floating around, and of course they're going to want to connect with each other and they're going to stick together. This force of attraction can hold atoms together in an ionic bond. That's what an ionic bond is it's like magnets with a positive and a negative end, the north pole and the south pole of a magnet. They stick together like that. That's an ionic bond. So let me give you an example. And I would like you to write these examples down because these are like really important ones. Sodium is Na, and it's in group 1, so it's all the way on the left of the periodic table. It has one electron in its outer shell. It likes to give it away. When you give an extra electron away, it makes it a positive ion because it's missing that extra negative charge. It's a positive ion. Now we call that Na positive, and you write it like this to show that it's an ion. Chlorine, Cl, is in group 17. That's the one right next to the noble gases. It is one electron short of a full outer shell, so it's got one little hole it wants to fill. It likes to take other atoms' electrons to fill it. And when it takes that electron, now it's got one extra negative charge. So it makes it a negative ion, which is Cl with a little negative sign. Now, if you've got more than one positive or negative charge, there's actually a number there. But remember, just like when you say like H2O, you don't have anything after the O because you assume it's a 1. There's nothing that you assume it's a 1 if it's plus or a minus like this. But if it's more than 1, you'll actually see +2 or -3 or something like that. Okay? Okay. Then, so the sodium ion and the chlorine ion attract each other and they stick together. And this actually forms sodium chloride, which is table salt. And that's just how you do it. That's it. Now, the cool thing about sodium chloride is that okay, so you've got two atoms, and one side has more electrons on it than the other side does. So The chlorine side of the sodium chloride is a little more negative than the sodium side, so it has a slightly positive charge on that side. Now, when you get a whole bunch of sodium chloride molecules together, the negative ends attach themselves to the positive ends, and so they line themselves up really nicely. So lots of sodium chloride molecules attract each other and they form crystals. And when you have crystals with a very definite crystal composition, if you remember that at all from 6th grade, then those crystals are structured because they've got ionic compounds with a slightly positive and a slightly negative end. Does that make sense? Then we get to try and name them. And there's a very specific way to name ionic compounds, and we get to practice this in class. The first half of the name is the metal's name, and remember the metals are on the left side of the periodic table, so that for our example would be the sodium. The second half is the non-metal's name, and that comes from the right side of the periodic table. You drop the end of whatever, like chlorine, you drop the INE, and you add IDE. So you have sodium chloride, and that's it. So now you get to practice. You're going to name the following compounds. You have BAI2, KBr, and MgF2. Now you don't have to worry about the numbers, you just have to look at what the elements are called and see if you can name it correctly. So pause here and try it with the periodic table. There's one in the back of your science book, and there's one in the back of your planner if you need one. And I can probably put one up for you because I'm cool like that. Push pause. All right, so this is barium iodide, potassium bromide, and magnesium fluoride. We took the iodine, the bromine, and the fluorine, and you've taken off the end and you've put IDE at it. Is that cool? I hope so. We'll play with it more tomorrow or whenever I see you next. Okay, so that was all ionic bonds. Now there's the second kind of bond, that's the covalent bonds, because you don't just have elements that are just on the left and just on the right of the periodic table. You've got, I mean, there's all kinds of stuff in the middle there. And so how do you connect with all of those? And that's where covalent bonds come in. And these form by sharing electrons, not stealing them. This tends to happen with at least one of the less reactive elements that you would find in the middle of the periodic table. Neither atom loses or gains electrons, they just share them. For example, and you don't have to write this down, carbon and oxygen in a carbon dioxide molecule, they form covalent bonds. Carbon has 4 outer electrons to share. Oxygen only needs 2. So this oxygen over here is going to share 2 of carbons, and this oxygen over here is going to share 2 carbons. So it's going to it's not taking carbons, because the carbon, it's kind of doing a figure 8 around both of them now. So they're shared. Sometimes the electron goes around carbon and sometimes it goes around oxygen, and they're sharing. But oxygen only needs to share 2 with carbon. And so oxygen also shares 2 with carbon. So carbon's getting 2 from oxygen as well, but they're sharing, so it's not really from. And then the other oxygen also, it shares 2 of carbons, and it takes 2 of its and gives it to the carbon, and so now everybody is full. And this is a really strong bond. And these are really hard to break. Now sometimes the bonds aren't symmetrical. And they leave the sides of the polar compound, slightly charged. This is called polar. And polar means you have a positive and negative end, kind of like magnets again. So sometimes with carbon dioxide, they line each other up. And so one end and the other end are the same, but with water has a definite sides because the two hydrogens are off. In this picture, they're off on the bottom here, okay? Because they can't make a Mickey Mouse, apparently. The hydrogens are off on the bottom, so the side with the hydrogens is slightly one charge, and the side with the giant oxygen, in compared to the hydrogen, is slightly the other charge. Does that make sense to you? So, so that's polar. So when water gets all crystallized, when you form ice, that's why all the Mickey Mouses have to line up, because all of the positive ends have to match up with all of the negative ends of their neighbors. All right, compound structures, last slide. Most ionic compounds make regular crystal structures, ionic compounds, because they have a positive and a negative end. It makes a strong crystal, but it also makes it rigid, which means it's easily broken. Covalent compounds, on the other hand, are individual molecules that don't connect well with the surrounding molecules. So this makes a less rigid structure, but less strong. And here's an example of a covalent crystal. So you've got your ionic crystals, which are really like this is how you make it, and this is the only way to make it, and it's very nice and neat. And then you have a covalent compound, and you can see that these they don't really, you know, fit together exactly perfectly. So there's, anyway, you can see how we need to have both in this world, and so I need you to understand both and how they're made and how to manipulate them a little bit. Okay, that is all of section 2. Thank you for playing. Have a lovely day.